peripheral angle ACB equals to peripheral angle AEB. Why they are equal to each other? Because of the fact that they both rest on the same chord AB. Okay? Peripheral angle ACB equals to peripheral angle AEB. And if we define peripheral angle AEB as theta, here angle AEB equals to theta according to our definition, then from this equation angle ACB equals to angle AEB equals to theta, we will derive that angle ACB is also equals to theta. Angle ACB also equals to theta. So you can write here that angle ACB equals to theta. So in triangle ADC, angle ADC equals to 90 degrees, angle ACD equals to theta. Therefore, this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles to 180 degrees. This angle must be equal to 90 degrees minus theta, because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. Okay? And exactly for the same reason, angle BAE must be also equal to 90 degrees minus theta. Okay? So in the next step, we will prove the right green triangle AEB. This triangle is similar to the right green triangle ADC. So why those two white green triangles are similar to each other? So first of all, I write it down. We prove the triangle AEB So why those two triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle ABE equals to angle ADC, and they are both equal to 90 degrees. So repeat again. Angle AB equals to angle ADC equals to 90 degrees. In addition, those two angles are both equal to theta, therefore they are equal to each other. So angle AEB equals to this angle that is actually angle ACD, and they are both equal to theta. I repeat again. Angle AEB equals to angle ACD, they are both equal to theta. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this angle, this is actually angle BAE, is equal to this angle, that is actually angle DAC. And they're both equal to 90 degrees minus theta, therefore they are equal to each other. Repeat again, angle BAE equals to angle DAC, they're both equal to 90 degrees minus theta. So we actually proved that all the angles of triangle ABE can go into all the angles of triangle ADC, therefore triangle ABE is similar, this is the sign of similar to triangle DAC, according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following equation is true. That AB over AD equals to AE over AC. I repeat again, AB over AD equals to AE over AC. AB over AD equals to AE over AC. So AB equals to 5, AD equals to 3, AE is the diameter of the circle, therefore it is equal to 2 times capital R over AC. AC equals to square root of 13 units according to what we already found out. So in conclusion, we found out that according to equation number 2, 5 over 3 equals to 2R over square root of 13 units over square root of 13 units. Here we multiply this equation number 2 by square root of 13 units. And we get that according to equation number 2, 5 over 3 times square root of 13 units equals to 2R. Here we divide this equation number 2 by 2, and we get that according to equation number 2, 5 times square root of 13 over 6 equals to R, the radius that we are looking for, equals to either 5 times square root of 13 over 6, or in terms of numbers, it is equal to a little bit more than 3 units. Okay, so we finish with the first method. In the next step, we will present to you the second method. In the second method, we'll use all the things that we already found out in the first method. So here from point A we draw perpendicular on BC. So this angle equals to 90 degrees according to our construction. This angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A, BC as D. We already found out that in the first method that AD equals to 3 units, DC equals to 2 units, and BD equals to 4 units. In the next step we will extend the perpendicular AD by a straight line until it touches the circle, and we will define the touching point of the extended AD in the circle as E. And we also have here rule number 1. According to rule number 1, if we have a circle so here it's called AB, this is called AB, intersects with called CD, this is called CD, at point O. Point O is the intersection point of chord AB with chord CD. Then the following equation is true, that AO times OB equals to CO times OD. Okay, again, if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can implement rule number 1 in our drawing, because in our drawing we have chord AE that intersects with chord BC at point D. Therefore, according to rule number 1, we get here that BD times DC equals to AD times DE. Okay. BD equals to 4 units, DC equals to 2 units, AD equals to 3 units, and DE is the missing 9 segment. So here we found out that 4 times 2, that is 8, equals to 3 times DE. Here we divide this equation by 3 and we get that DE equals to 8 over 3 units. So we can write here that D equals to 8 over 3 units. So in the next step I will present to you rule number 2. According to rule number 2, if we have this circle Inside this circle we have chord AB. This is chord AB that intersects with chord CD. This is chord CD at 90 degrees. At the intersection point, they create 90 degrees with each other. So all the angles here are equal to 90 degrees. We define the intersection point as point O. We define side AO as A. Side AO equals to A units in its length, side OB equals to B units in its length, side CO equals to C units in its length, and side OD equals to D units in its length. So if chord AB intersects with chord CD at 90 degrees, then the following equation is true, that 4 times R squared, R is the radius of this circle that contains the two chords, equals to A squared plus B squared plus C squared plus D squared. I'll repeat again. If chord AB intersects with chord CD at 90 degrees, then the following equation is true, that 4 times R squared equals to A squared plus B squared plus C squared plus D squared. Actually, we can implement rule number 2 in our drawing, because in our drawing we have chord BC that intersects with chord AE at 90 degrees. Here, all the angles here around point D are right angles. Why? Because according to the rule that the sum of the angles from one side of a straight line equals to 90 degrees, all the angles here must be equal to 90 degrees. Okay? So here again, chord AE intersects with chord BC at 90 degrees, therefore we can implement rule number 2 here, and according to rule number 2, we will get that 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. I'll repeat again. According to rule number 2, we get that 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. I'll repeat again. According to rule number 2, because of the fact that chord AE intersects with chord BC at 90 degrees, then 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. So 4 times R squared equals to BD squared. BD equals to 4, so BD squared is 4 squared, that is 16, plus DC squared. DC equals to 2, so DC squared is 2 squared, that is 4, plus AD squared. AD equals to 3, so AD squared is 3 squared, that is 9, plus DE squared. DE is 8 over 3, so DE squared is 8 over 3 squared, that is 64 over 9. So in conclusion, we found out that 4R squared equals to 16 plus 4 plus 9 plus 64 over 9. That is to say, 16 plus 4 is 20, and 20 plus 9 is 29. So we have here 29 plus 64 over 9. So here we'll multiply 29 by 9 and then we divide it by 9 in order to have a common factor with this expression. So 29 times 9 is 261 plus 64 over 9. 261 plus 64 is 325 over 9. So in conclusion, we found out that 4 times R squared equals to 325 over 9. Here we'll divide this equation by 4. And we get that R squared equals to 325 over 9 times 4, that is 36. Here we'll take a root out of this equation and we get that r, but before that we know that we substitute, so r squared equals to 325, so we substitute 325 by 25 times 13 over 36. Here we take out of this equation and we get that r equals to the square root of 25 is 5 over square root of 36 is 6 over square root of 13. So here we found out that the radius of the circle that we are looking for, it is equal to either 5 over 6 times square root of 13 units, so in terms of numbers, it is a little bit greater than 3 units. We finished with the second method. The next step I present to you how to find out the radius of the circle that blocks triangle ABC according to the second method. Okay? According to the first method. So according to the first method, here in the first method we define angle ABC as theta, and we have a special formula to find out the area of any triangle. If we have triangle ABC, that could be any triangle. This is triangle ABC. We know that the angle between side AB and side AC is theta. The length of side AB is A units. Side AC equals to B units in its length, and side BC equals to C units in its length. Okay. So, and according to the new formula, the area of this triangle ABC, here the area of triangle ABC will be equal to A times B times sinus theta over 2. Okay, so we use this formula in order to find out the area of our triangle ABC. So according to this formula, the area of our triangle ABC, it will be equal to AB times BC over sinus theta over 2. That is to say, the area of this triangle ABC is equal to AB, that is 5, times BC, that is 6, times sinus theta over 2. But we already know that the area of our triangle ABC equals to 9 units. So we can substitute the area of triangle ABC by 9, and 9 equals to 5 times 6 is 30 times sinus theta over 2. So 9 equals to 15 times sinus theta. We divide this equation by 3 and we get that 15 over 3 is 3, 15 over 3 is 5, so it is 5 times sinus theta equals to 9 over 3 is 3. So here we divide this equation by 5 and we get that sinus theta equals to 3/5. Sinus theta equals to 3/5. But we actually have the trigonometric identity that cosine theta equals to the square root of 1 minus sinus square theta. Okay? So cosine theta equals to the square root of 1 minus sinus theta equals to 3/5, therefore sinus squared theta will be equal to 3/5 squared, that is 3 squared is 9 and 5 squared is 25. So cosine theta equals to the square root of, here we will multiply 1 by 25 and then we will divide it by 25 in order to have a common factor with this expression. So here 25 minus 9 over 25. So here we get that cosine theta equals to the square root of 25 minus 9 is 16 over 25. So cosine theta equals to square root of 16 is 4 and square root of 25 is 5. So in conclusion, we found out that cosine theta equals to 4/5. Cosine theta equals to 4/5. In the next step, I will present to you the law of cosines and we will implement the law of cosines in our triangle ABC. Okay. I will remind you the law of cosines quickly because we have already mentioned it a couple times in the past. So what is the law of cosines? The law of cosines is true in any triangle. So this is the law of cosines. So if you have triangle ABC that could be any triangle, this is triangle ABC. The angle between side AB and side AC is theta. Side AB equals to A units in its length. Side AC equals to B units in its length. And side BC equals to C units in its length. Here we get that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Okay. We will implement the law of cosines in our triangle ABC. So here, according to the law of cosines, we will get that cosine theta equals to, here it is, AB squared, that is 5 squared is 25, plus BC squared, BC is 6, so BC squared is 6 squared, that is 36, minus AC squared over 2 times AB, that is 5, times BC, that is 6. Here we have already found out that cosine theta equals to 4/5, so we can substitute cosine theta by 4/5. So 4/5 equals to 25 plus 36 is 61 minus AC squared over 5 times 6 is 30 and 30 times 2 is 60. Here we will multiply this equation by 60 and we get that 60 times 4 over 5 equals to 61 minus AC squared here 60 over 5 is 12 and 12 times 4 is 48, so 48 equals to 61 minus AC squared. Here we subtract from this equation 48 and also add AC squared simultaneously, and we get that according to this equation, AC squared equals to 61 minus 48 is 13, so AC squared equals to 13. We take a root out of this equation and we get that AC equals to the square root of 13 units. So here we found out that AC equals to the square root of 13 units. In the next step I will present to you a new formula that gives us the radius of a circle that blocks triangle, exactly like in our drawing. This circle blocks triangle ABC. So the radius of any circle that blocks triangle, that is to say capital R, is the radius. It will be equal to the multiplication of the sides of the triangle that is blocked by the circle. In our case, it will be equal to AB times AC times BC. Over 4 times the area of the triangle that is blocked by the circle, or over 4 times the area of the triangle that is inscribed by the circle. In this case, we are talking on triangle ABC. Triangle ABC is inscribed by this circle, so it is 4 times the area of triangle ABC. So actually we found out that the radius of this circle that blocks triangle ABC will be equal to AB is 5 units, AC is square root of 13 units, and BC is 6 units, over 4 times the area of triangle ABC. It is given us in the question that the area of triangle ABC equals to 9 square units. So it is 4 times 9. So the radius of the circle that blocks triangle ABC will be equal to 5 times 6 is 30, times square root of 13, over 4 times 9 is 36. Here we will divide both the numerator and the denominator on this side of the equation by 6, and we get that the radius of the circle that blocks triangle ABC is equal to 30 over 6 is 5, so it is 5 times square root of 13 over 36 over 6 is 6. So the radius of this circle that blocks triangle ABC is equal to either 5 times square root of 13 over 6 units. So in terms of numbers, it is a little bit greater than 3 units. We finished with the first method. In the next step, I will summarize the lecture. We'll start with the first question, of course. In the drawing, we have a big circle that blocks triangle ABC. Triangle ABC is inscribed by the big circle, and triangle ABC also blocks the small circle, so the small circle is inscribed by triangle ABC. It is given as the question that AB is the diameter of the big circle, and the radius of the big circle equals to 13 units, while the radius of the small circle equals to 4 units. and we want to find out the area of the blue shape. Okay, so first of all we defined the center of the small circle is O, and we defined the point of tendency B with the small circle as M. We defined the point of tendency of tangent AC with the small circle as N. And we define the point of tendency of tangent AB, that is also the diameter of the big circle. We define the point of tendency of tangent AB with the small circle as L. Then we presented to you rule number 1, that the tangent to a circle is perpendicular to the radius drawn to each point of tendency. And we join points O and M together by a straight line. Point O is the center of the circle, the small circle. Point M is the point of the small circle itself. This is exactly the definition of a radius. So OM is the radius of the small circle that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent CB with this small circle. That whenever we have a radius that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius MO. So if CB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle will also equal to 90 degrees. Likewise, we join points O and N together by a straight line. O is the center of the small circle. N is the point of the small circle itself. So this is exactly the definition of a radius. That is to say, ON is the radius of the small circle that is equal to 4 units, and we have the radius ON that is drawn to the point of tendency. That is to say, the radius ON it is drawn to point N, that is the point of tendency of tangent AC with this small circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NO. So if AC is perpendicular to NO, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. And we also have the rule that any peripheral angle that rests on the diameter of a circle is equal to 90 degrees. Here, peripheral angle ACB rests on AB, that is the diameter of the big circle, therefore it is equal to 90 degrees. So this angle also equals to 90 degrees. So in quadrilateral ONCM, we have 1, 2, 3 right angles. Okay. In quadrilateral ONCM, we have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle MON. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation, and we found out that the missing angle MON equals to 90 degrees. So this angle equals to 90 degrees, so we actually found out that in quadrilateral ONCM we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, must be at least a rectangle, if not a square. So we relate to quadrilateral ONCM as a rectangle, but we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ONCM, ON equals to CM. ON equals to CM. But we have already found out that ON equals to 4 units. It is the radius of the small circle. ON equals to 4. And from this equation, 4 equals to ON equals to CM. We will derive that CM is also equals to 4 units. Here, CM also equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that OM equals to NC. OM equals to NC, but we already found out that OM equals to 4 units. It is the radius of the small circle. Here OM equals to 4 units, and from this equation 4 equals to OM equals to NC, we will derive that NC is also equals to 4 units. Okay, so here NC equals to 4 units, so in quadrilateral O and CM, all of its sides are equal to each other, therefore quadrilateral O and CM is not a rectangle but a square. Then we defined side AC of triangle ABC as A, we define side CB as B, and we define side AB as C. We define side CB as B, and we define side AC as C. Here, AC equals to A, CB equals to B, and AB equals to C. And we found out the length of line segment AN. From the drawing it is very easy to see that AN equals to AC minus NC. Again, AC minus NC equals to AN. Repeat again, AN equals to AC minus NC, AC equals to A, and NC equals to 4. So in conclusion, we found out that AN equals to A minus 4. Here, AN equals to A minus 4. Then we found out the length of line segment MB. From the drawing it is very easy to see that the length of line segment MB it is equal to CB minus CM. Again, CB minus CM equals to MB. Again, MB equals to CB minus CM, and CB equals to B. CM equals to 4. So in conclusion, we found out that MB equals to B minus 4. So actually we found out that MB equals to B minus 4 and AN equals to A minus 4. Then I presented to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. Again, the lengths of two tangents from a common external point to a circle are equal. So here we have the common external point A. For the common external point A, we have two tangents for the small circle, tangents AL and tangent AN. According to rule number 2, they must be equal to each other. So here AN equals to AN according to rule number 2. But we have already found out that AN equals to A minus 4. So we can write here that AN equals to A minus 4. And from this equation AN equals to A minus 4. We will derive that AL is also equals to A minus 4. Here, AL is also equals to A minus 4. Then we focus on the right, on the common external point B. From the common external point B, we have two tangents to this circle. Tangent BL and tangent BL. Okay. Tangent BL and tangent BM. And according to rule number 2, they are equal to each other. Here BL equals to BM according to rule number 2. But we have already found out that BM equals to B minus 4. BM equals to B minus 4, so we can write here that BM equals to B minus 4, and from this equation BL equals to BM equals to B minus 4, we derive that BL is also equals to B minus 4. Here BL is also equals to B minus 4. So in conclusion, we found out that BL equals to B minus 4 and AL equals to A minus 4. And AB is defined as the diameter of the big circle, therefore it is twice as long as the radius. So AB equals to 2R, if R is the radius of the big circle. And we have already, it is given as the question that the radius of the big circle equals to 13 units. Therefore the diameter must be twice as long as the radius. That is to say, the radius must be 13 times 2, that is 26 units. So the diameter of the circle equals to 26 units. From one side, the diameter of the big circle equals to 26 units. From the other side, from the drawing, you can see that the diameter AB equals to AL plus LB. Again, the diameter AB equals to AL plus LB. AL equals to A minus 4. LB equals to B minus 4. AL equals to A minus 4, LB equals to B minus 4. So in conclusion, the diameter equals to A minus 4 plus B minus 4. here. So the diameter that is AB that is equal to 26 units, it is equal to A plus B, and minus 4 plus minus 4 is minus 8. So here, according to equation number 1, I found out that 26 equals to A plus B minus 8. We added to this equation number 1, 8, and we found out that 26 plus 8 is 34, and 8 minus 8 is 0. So in conclusion, we found out that according to equation number 1, A plus B equals to 34. Here we squared this equation number 1, and found out that AB squared equals to 34 squared. We opened the brackets on both sides of this equation number 1, and found out that AB squared equals to A squared plus B squared plus 2 times AB, and it is equal to 34 squared. 34 squared equals to 1156. So in conclusion, we found out that according to equation number 1, A squared plus B squared plus 2 times AB equals to 1156. Then we focus on the right triangle, triangle ABC. According to the Pythagoras theorem on the right triangle, triangle ABC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB squared equals to AC squared plus BC squared. AB equals to 26, so AB squared is 26 squared, that is 676. And it is equal to AC squared. AC is A, so AC squared is A squared, plus BC squared. BC is B, so BC squared is B squared. So in conclusion, we found out that 676 equals to A squared plus B squared. And because of the fact that A squared plus B squared equals to 676, it means that you can substitute A squared plus B squared in equation number 1 by 676. We did it, and we got that according to equation number 1, A squared plus C squared, that is equal to 676 plus 2AB equals to 1156. We subtracted 676 from this equation number 1, and we found out that 2 times AB equals to 1156 minus 676 is 480. So we found out that 2 times AB equals to 480. Here we divided this equation number 1 by 2. So AB equals to 480 over 2, that is 240. Then again we divided equation number 1 by 2, so AB over 2 equals to 240 over 2, that is 120. So in conclusion, we found out that AB over 2 equals to 120. Then what is the area of the green of the blue shape? From the drawing, it is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. Okay, again, the area of the blue shape equals to the area of triangle ABC plus minus the area of the small circle. The area of triangle ABC equals to the base of the triangle that is AC times the height to the base that is CB over 2. AC times CB over 2 minus the area of the small circle that is pi r squared when r equals to 4 units. So here the area of triangle ABC equals to AC that is A times CB that is B over 2. So the area of triangle ABC equals to A times B over 2 minus the area of the circle that is pi r squared. We have already found out that the area that AB over 2, here, AB over 2 equals to 120. So we substituted that AB over 2 by 120. So it is 120 minus pi r squared. Pi equals r equals to 4 units, so r squared is 4 squared, that is 16. So the area of the small circle that is pi r squared is 16 pi. So in conclusion, we found out that the area of the blue shape equals to either 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. Okay, so we finished with the first question. Then I presented to you the second question, and we solved the second question in three different methods. We start with the first method. Here in the drawing, we have this circle that blocks triangle ABC. Now triangle ABC equals to 9 square units. Side AB equals to 5 units. Side BC equals to 6 units. And we want to find out the area of the circle that blocks triangle ABC. Okay. So we start with the first method. From point A, we move perpendicular on BC. This angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. Okay, then we actually know that the area of the triangle equals to 9 square units. So here, 9 square units equals to the area of triangle ABC. But the area of triangle ABC equals to the base of the triangle that is BC times the height of the base that is AD over 2. Here, BC is the base times the height that is AD over 2. So here, the area that is 9 square units equals to BD that is 6 times AD over 2. 6 over 2 is 3, so in conclusion we found out that 9 equals to 3 AD. We divided the equation number 1 by 3 and we found out that AD equals to 3 units. So here we can write down that AD equals to 3 units. Then we focus on the right triangle ABD. On the right triangle ABD, the square of the hypotenuse equals to the sum of the squares of the perpendiculars according to the Pythagoras theorem. That is to say, AB square equals to AD square plus BD square. AB equals to 5, so AB square is 25. That is equal to AD square. AD is 3, so AD square is 3 squared, that is 9, plus BD square. Here we subtracted 9 from this equation number 1, and we found out that 25 minus 9 is 16, so 16 equals to BD square. We took out of this equation number 1, and we found out that BD equals to 4 units. Here, BD equals to 4 units. Then we found out the value of DC. For the drawing, it is very easy to see that DC equals to BC minus BD. DC equals to BC minus BD. BC is 6 units, BD is 4 units, so in conclusion we found out that DC equals to 6 minus 4, that is 2 units. Then we focus on the right triangle ADC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here, that is to say, AC square equals to DC square plus D square plus DC square. Again, AC square equals to DC square plus AD square. So here, AC square equals to DC square. DC is 2, so DC square is 2 squared, that is 4, plus AC square. AC is 3, so AC square is 3 squared, that is 9. So in conclusion, we found out that AC square equals to 4 minus 9, that is 13. So AC square equals to 13 units. We took out of this equation and found out that AC equals to the square root of 13 units. AC equals to the square root of 13 units. Then we defined the center of this circle as O, and we joined points A and O together by a straight line. Then we extended line segment AO by a straight line until it touches the circle at point E. AE passes for the center of the circle, therefore it is the diameter of the circle. That is to say, it is equal to 2 times r. If r is the radius of the big circle, then the diameter is 2r. Okay, so here we have angle, then we join points A and B together by a straight line, and we created angle ABE that rests on AE, that is the diameter of a circle, therefore it is equal to 90 degrees according to the rule that any peripheral angle that rests on the diameter of a circle must be equal to 90 degrees. So I repeat again that angle AB equals to 90 degrees according to the rule that I mentioned. And then we have also another rule that peripheral angles that rest on the same chord are equal to each other. So here those two, we have here those two angles are both rest on the same chord that is actually chord AB, therefore they are equal to each other. According to the rule that peripheral angles that rest on the same chord are equal to each other. Okay, so peripheral angle ACB equals to peripheral angle AEB according to the rule that I mentioned. So if we define angle AEB is theta, then from this equation ACB equals to AEB equals to theta, we derive that angle ACB also equals to theta. Here angle ACB also equals to theta. So here in triangle ADC, this angle equals to theta, this angle equals to 90 degrees, therefore this angle must be equal to 90 degrees minus theta, and the same thing is true here, so this angle must be also equal to 90 degrees minus theta. Then we prove that those two right triangles are similar to each other. Why they are similar to each other? First of all, those two angles that are equal to each other, they are both equal to 90 degrees. Those two angles that are equal to each other, they are both equal to theta. And those two angles that are equal to each other, they are both equal to 90 degrees minus theta. So those two triangles are similar to each other according to angle similarity rule. Okay. And from the fact that those two triangles are similar, that those two triangles are similar to each other, we will derive that AB over AD equals to AE over AC. AB is 5, AD is 3, AE is 2R, this is the diameter of the circle, and AC is 13. So 5 over 3 equals to 2R over square root of 13. We multiply this equation by square root of 13. And found out that 5 over 3 times square root of 13 equals to 2R. We divided this equation number 2 by 2. And found out that the radius of the circle that proves triangle AC equals to either 5 times square root of 13 over 6 units, or in terms of numbers, the radius of the circle that proves triangle ABC equals to a little bit greater than 3 units. We finished with the first method. Then I presented to you how to find out the radius of the circle that blocks triangle ABC according to the second method. From point A, we draw perpendicular on BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. According to the first method, AD equals to 3 units, DC equals to 2 units, and BD also, equals to 4 units. Then we extended line segment AD by a straight line until it touches the circle at point E, and then I presented to you rule number 1. According to rule number 1, if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Again, if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Okay? Actually, we can implement rule number 1 in our drawing, because in our drawing chord BC intersects with chord AE at point D, therefore BD times DC equals to AD times DE. BD times DC equals to AD times DE. BD is 4, DC is 2, AD is 3, and DE is the missing line segment. So we found out that 4 times 2 is 8, and 8 equals to 4 times DE. We divided this equation by 3, and found out that DE equals to 8 over 3. Here DE equals to 8 over 3. Then I presented to you rule number 2. According to rule number 2, if chord AB intersects with chord CD at 90 degrees, that is to say they are connected with each other 90 degrees at the intersection point, then the following equation is true, that 4 times R squared equals to A squared plus B squared plus C squared plus D squared. R is the radius of the circlet that contains the two chords. We can actually implement rule number 2 in our drawing, because in our drawing we have chord AE that intersects with chord BC at 90 degrees. All the angles around point D is 90 degrees. Therefore we can implement rule number 2 in our drawing. According to rule number 2, 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. Repeat again. 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. So 4 times R squared equals to BD is 4, BD squared is 4 squared, that is 16, plus DC squared. DC is 2, so DC squared is 2 squared, that is 4. Plus AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus DE squared. DE is 8 over 3, so DE squared is 8 over 3 squared, that is 64 over 9. So here 16 plus 4 is 20, and 20 plus 9 is 29. Okay, so in conclusion, we found out that 29 plus 64 over 9 equals to 4R squared. Here we multiply 29 by 9 and then we divide it by 9 in order to overcome factor with this expression. We found out that 29 times 9 is 261 plus 64. So 261 plus 64 is 325 minus 325 over 9. So in conclusion, we found out that 4R squared equals to 325 over 9. Okay? R squared equals to, we divided this equation by 4 and found out that 325 over 9 times 4 is 36. So R squared equals to 325 over 36. Here we substituted 325 by 25 times 13 over 36. We took out of this equation and found out that R equals to, the square root of 25 is 5, over square root of 36 is 6. So R equals to 5 over 6 times square root of 13. Again, R, the radius of the circle that blocks triangle ABC, equals to either 5 times square root of 13 over 6, or in terms of numbers, it is a little bit greater than 3 units. Okay? Thank you very much.